In this video, we're going to talk about 1.1 Objective 3, where we evaluate composite functions and find their properties. So if f of x is equal to 1 over x cubed plus 3, what is f of 2? And then find f of z squared. So let's first stick 2 in to x cubed to get 8, and 8 plus 3 is 11. So f of 2 is 1 over 11. F of z squared to the third power, z to the sixth. This can be 1 over z to the sixth plus 3. Now let f of x be equal to 2x plus 1 and g of x be 4 over x minus 1. Let's find f of g of 2/3. So first, let's find g of 2/3. It's going to be 4 over 2/3 minus 1. 4 over negative 1/3 is going to be a negative 12. And then f of negative 12 is going to be 2 times negative 12 plus 1. It's negative 24 plus 1 is a negative 23. It's going to be negative 23. G of f of 4. So f of 4 is 9. So g of 9 is 4 over 8 is 1/2. And g of f of x. So 4 over, and then in place of this x goes 2x plus 1 minus 1 is going to be 4 over 2x is going to be 2 over x when we simplify. If f of x is the cube root of x and g of x is equal to x squared minus 8, find f of g of 4, f of 64, g of f of x, and f of g of x. So start with f of g of 4, plug 4 into g. 4 squared is 16, 16 minus 8 is 8. Then we want the cube root of 8 is going to be 2. F of 64, so the cube root of 64 is going to be 4. Then plug that 4 back in for the x here. The cube root of 4 will be my answer. G of f of x. So we're going to write down g and replace the x in it with f of x. So this is going to be x to the 2/3 power minus 8. Since this root can be written as a fractional exponent of x to the 1/3, and when I raise a power to a power, I multiply the exponents. Now we're going to stick g in as the input in f, so we get the cube root of x squared minus 8. Let's evaluate each expression using the graphs to the right there, where y equals f of x is this black function, and y equals g of x is this pink function down here. So g of f of 4, so f of 4 is going to be 7. So we want, g of 4. G of 4 is going to be 1. So we want f of 1, and f of 1 is going to be 3. Now we want g of f of 2. So f of 2 is 4. G of 4 is 1. F of g of 7. So we're going to have f of g of 7 is 4. And f of 4 is 7. G of f of 5. So g of f of 5 is 6. And g of 6 is 3. F of 2. So f of 2 is 4. And f of 4 we've already found was 7. Now we want G of f of g of 8. Wow. G of f of g of 8. So g of 8 is looking like 4. F of 4 is 7. And g of 7 we haven't found yet is 4. Let me check that again. G of f of g of 8. G 4. F of 4 is 7. G of 7. Yeah, 4. Okay. Let's go ahead and look at the next one here. So let's use the table instead. I like tables a whole lot better usually than graphs for this stuff. So g of -3 is going to be a -1. So that's h of -1. H of -1 is a -1. I just found g of -3 there to get the -1. And then I found h of -1 to get -1. G of f of -1, so f of -1 is -3. G of -3 is -1. H of -4, so h of -4 is -4. H of -4 is -4. G of h of f of -2. So G of h f of -2 is -1. H of -1 we found already is -1. G of -1 is -2. F of f of 0. So f of 0 is 0. F of 0 is 0. F of 0 is 0. That's 0. H of -4. So that's -4. F of h of g of -3. F of h g of -3 is -1. H of -1 is -1. F of -1 is -3. G of f of h of -2. G of f of h of -2 is 0. F of 0 is 0. And G of 0 is -4. G of g of g of -1. So G of -1 is -2. G of -2 is -3. And G of -3 is -1. F of h of -4. So h of -4 is -4. F of -4 is -2. And f of -2 is -1. Let capital F of x equal 1 over x minus 8. Simplify the following expression. Capital F of y cubed is 1 over y cubed minus 8. G of x equals x to the 5th. Capital F of x is equal to 1 over x minus 8. Find f of g of y. So g of y is going to be y to the 5th. F of y to the 5th is going to be 1 over y to the 5th minus 8. look at number 8 now. Let f of x be equal to x squared minus 1 and g of x equal x cubed. Find the expression f of g of w. So g of w is going to be w cubed. F of w cubed is going to be w cubed squared minus 1, which is w to the 6th minus 1. F of x is equal to x squared minus 7. G of x is equal to x to the 5th. Find g of f of u. So f of u is going to be u squared minus 7. G of u squared minus 7 is going to be u squared minus 7 to the 5th. This gets into something that looks like a difference quotient here. F of x is equal to x squared minus 4. Simplify the expression f of x, f of 2 plus h minus f of 2 over h. So this is going to be 2 plus h squared minus 4 minus, and then when I stick in 2, 4 minus 4 is 0 over h. So 2 plus h times 2 plus h is 4 plus 4h plus h squared minus 4 over h. 4 minus 4 is 0. Factor out the h, and that's going to be 4 plus h over h. Remember that h can't be 0 here because of the domain. So we're going to be allowed to cancel that out and say that this is 4 plus h, or h plus 4. Just remember h right now cannot be 0. Simplify the expression f of x. So 1 over x minus 2 minus 2. Let's multiply top and bottom by x minus 2. I'm going to get x minus 2 over 1 minus 2x plus 4 is x minus 2 over 5 minus 2x. Now, g of capital F of x here is going to be something to the 4th. Capital F is 1 over x minus 5. And then little f is being plugged into big F. So little f is x squared minus 6, like that. So this is going to be 1 over x squared minus 11 raised to the 4th. Because we know it's 1 to the 4th, we could also write this as x squared minus 11 to the 4th power with a 1 up there. Either is correct. I'm going to write it this way because I feel this is a little more simplified. F of the square root of x plus 3. So square root of x plus 3 squared minus 3. Watch out, when I square a square root, I get an absolute value. I don't just, I'm sorry, nope, this is going to go away. When I square root a squared, I get an absolute value. So this is going to be x plus 3 here, minus 3. So that's going to be x, because those functions were inverses of one another. But I have to be careful because this wasn't restricted. So let's go ahead and h of x is quantity x to the 9th minus 7 squared. What are the possible choices for outer and inner functions of f? So we want the composition f of g. So g to be the inner function, the easiest choice here is x to the 9th minus 7, and the outer function make it x squared. And so that's going to be squared x to the 9th minus 7. And no restrictions on these. We have inner function is odd and goes from negative infinity to infinity, and no restrictions on the outer function here. So we get everything. Let's keep going here. Find possible choices for outer and inner functions for this. So outer function is going to be the square root function. And the inner function is going to be x to the 6 plus 12. That's the easiest way to decompose those functions. F of x be the absolute value of x, and g of x equal x squared minus 4. Compose f and g, where g is the inner function, so we're going to have absolute value of x squared minus 4. And the domain is going to be all real numbers. So let f be the absolute value of x and g be x squared minus 10, and capital G be 1 over x minus 9. Find f of g. So we want the absolute value of 1 over x minus 9 squared on the inside, which is, this is minus 10 on the inside as well. Like that. So this is absolute value of 1 over x minus 9 squared minus 10, like so, is my composition. And then we're asked to find the domain of that. So x can't be negative 3 or 3, which would make a 0 in the denominator on the inside. So we have negative infinity to negative 3, union negative 3 to 3, union 3 to infinity. I'm sorry, 9. 9's the only bad number. So negative infinity to 9, union 9 to infinity. There we go. I was looking at that like it was x squared minus 9 instead of x minus 9 squared. So sorry about that. Let's keep going here. F of x equals absolute value of x. G of x is x to the 4th minus 3. Capital G of x is 1 over x minus 2. Composite G of f, capital G of f. So plug f into G. We get absolute value of x to the 4th is the same thing as x to the 4th. So I don't need absolute value bars there really. X to the 4th minus 3 gets plugged into capital G. 1 over x to the 4th minus 3 minus 2 is 1 over x to the 4th minus 5. And so 1 over x to the 4th minus 5. And bad numbers are x to the 4th equals 5. X equals plus or minus the 4th root of 5. So negative infinity to negative 4th root of 5, negative 4th root of 5 to positive 4th root of 5, and 4th root of 5 to infinity. That's G. Now let capital G be 1 over x minus 11 and determine the composition of capital G of capital G. 1 over x minus 11 minus 11 times x minus 11 over x minus 11. So x minus 11 over 1 minus 11x plus 121. X minus 11 over 122 minus 11x. The domain here is going to be that x can't be equal to 11 for the original function, and x can't be equal to 122 over 11, which is slightly bigger than 11. So we have negative infinity to 11, union 11 to 122 over 11, union 122 over 11 to infinity. All right. G of x equals 2x minus 3. Find f of x so that h of x equals f of g of x. So f of 2x minus 3 equals 9 over 2x minus 3. F is 9 over x. It's pretty straightforward. Didn't need to use inverse functions for that, but that is a possibility to help us find answers to questions like that. Let g of x be equal to x squared plus 4. Find the function f that produces the composition f of g of x equals x to the 4th plus 8x squared plus 23. Let's go ahead and see if I can factor this. Let's complete the square here if I can. So x squared plus 4 squared, that's going to be 16, plus another 7 is going to give me 23. So this is going to be f of g of x is equal to this, where this is my g of x, so my f of x has to be x squared plus 7. Make sure that that's right and check it. X squared plus 4 squared plus 7, x to the 4th plus 8x squared plus 16 plus 7 is going to be x to the 4th plus 8x squared plus 23. Right, that's what I want. X squared plus 7 for my f of x. All right, and then 22, g of x equal x to the 3rd plus 4. Find a function f that produces the given composition g of f of x equals x to the 3/5 plus 4. Well, f is going to have to be the 5th root of x, or x to the 1/5. Either of those would work, but since this is in rational exponent form, let's keep that in rational exponent form. A few more problems here, almost done. Assume that f is an even function and g is an odd function. Assume that f and g are defined at all real numbers. Use the table to evaluate the given compositions. So this means that f of negative x is equal to f of x. This means f or g of negative x is going to be equal to negative g of x when they tell us that f is even and g is odd. So we might need to use that here since they only gave us positive numbers here. So g of negative 1 is going to be a positive 3. F of 3 is going to be 4. f of -4 is going to be the same as f of 4 is going to be -2. So g of -2, we need to look at g of 2, get the opposite of that. That's going to be 2. G of -3 is going to be the opposite of this. That's going to be 4. F of 4 is a -2. G of -2 is a +2. F of +2 is a -1. G of -1. So G of -1 is going to be a +3. G of 3 is a -4. F of G of 0 minus 1. So G of F of G of 0 minus 1. So this is going to be the same thing as, see, since G is an odd function, that's going to have to be 0. G of 0 is going to have to be 0. We talked about that earlier. So that's f of -1 is going to be 3. F of G of -2. So G of -2 is 2. G of 2 is -2, and F of -2 is -1. F of -4 is a -2. F of -2 is a -1. And G of -1 is a +3. G of -1, that's 3. G of 3 is -4. G of -4 is a +1. So a few more problems here. Determine a polynomial f that satisfies the following properties. Determine the degree of f. Then substitute a polynomial of that degree and solve for its coefficients. So f of f is equal to 16x minus 15. So we're going to want to have 4 times something that's 4x. And then we're going to have minus something here and minus something out here. 4 times 3 is going to give me -12, and -12 minus 3 is going to give me -15. So f of x is going to be 4x minus 3. Determine a polynomial that satisfies the given properties. Hint, determine the degree of f. Then substitute the polynomial of that degree and solve. So this is going to have to be quadratic. So this is going to have to be x squared plus something squared plus that something probably. Let's go with 10. 10 squared is 100. Plus 10 is 110. 10 plus 10 is 20. So this is going to be x squared plus 10. Suppose that f and g are even functions with f of 16 equal to 16 and g of 16 equal to -16. Evaluate f of g of 16. So f of g of 16 is the same thing as f of 16 is equal to 16. And g of f of negative 16, so g of 16 is going to be negative 16. And that's it for this video. We'll come back next time and keep it talking about more topics here. From 1.1, we'll look at objective 4 and talk about symmetry. See you for the next video.